Right? Fantastic. Thanks so much for having me. I am a NICU dietitian and I'm excited to talk about growth and how babies grow, and then specifically what we're going to talk about in this talk is doing that by Fortifiers and the cream product. So I'm really excited that there's so many hospitals represented here today. That's really exciting, and hopefully you can meet some people from other areas. Yeah, so I'm going to go ahead and get started with this. I also talk for a couple of other people, including the fact that I speak for the National Cattlemen's Beef Association and the Texas Beef Association as a cattle rancher. I am a 5th generation Texas cattlewoman, and that is one of my most fun accomplishments. This is at my ranch, and so I know a lot about cow nutrition as well, and cow's milk from that perspective. I don't have dairy cows, I have all beef cows. And so I do like my hamburger and my steak in particular, but all lean protein. You can have a lean hamburger and lean steak. But also I am a member of the Prolactin Nutrition Advisory Council Committee, the NAC, and you can reach us. We're a group of dietitians. I like to call us super users, because it sounds like superheroes in a sense. Terry is very hard to follow, can I just say? I'm going to have to figure out a way to fit in George Clooney into my next talk. I'll find a way. If anything, I like a challenge. So, but you can. We have the Nutrition Advisory Committee from Prolacta and also the Nursing Practice Advisory Committee. You can reach both of those groups by nac@prolacta.com or NPAC, Nursing Practice Advisory Committee. And like I said, we're just clinicians that have been using the products for a long time. So if you have a question about like, hey, tell me I got a 23-weeker, you know, and we've tried this and this and this, and what do you think now? It's just your phone a friend to another expert. So we're going to talk about the challenges of premature babies and what they face, the different types of human milk fortifiers, and different ways that we can strategize to improve those human milk products solutions for our babies. Well, we're talking about making them grow and making their brains grow. I worked for about 15 years at Texas Children's Hospital as a NICU dietitian and also a research dietitian. And Texas Children's Hospital is the largest NICU in the country. We're a level 4 and have 175 beds.
Wow.
Yeah. It's a country. It is. It's actually in 2 buildings. So when we expanded and built a new building, and we added about 50 more beds at that time, and so that's what's brought us up to that. Now our census is around 130, 140 probably on a regular basis.
Wow.
I did hear from our pharmacist that we write about 80 TPNs a day, so that are all due by noon. Right? So you guys have that rule too. So I'm at 80 TPNs all due by noon. Thanks, guys. So in our first building is kind of the center picture there. That's our group on rounds too. Like Terry had, you know, how rounds are important, and those discussions at the bedside are really important. That first hospital building is our pod system kind of, so it's an older school design. So it's our pod system. When we built the new building, all of those are private rooms. And so people love that. So those are all of our high-risk deliveries that we now deliver at that building, and they each get a private room. This is a private room, even though you see a bunch of cribs in here. This is one of our multiples rooms, and so that is for one family. And I still remember the day that the last of the sextuplets went home. Was the day that the Quints were born. And we filled it right up again. So we have a lot of babies, we have a lot of experience. So even though I am definitely a Texan, I love Texas, born and raised, and everything's bigger in Texas, including our NICUs. But what more so I want to get across the point of, not just because, you know, the biggest is not always the best. Sorry, you know, too. And I'll share with you sometimes some of the things that we don't always get right. But what I hope to share with you most of all is that we've learned a lot. So we've been using the human milk-based HMF because we're a CE talk right today, so I'm going to avoid any brand names as much as possible. But we've been using human milk-based HMF for over 10 years, since like 2006, through thousands of babies. So if you are a hospital that is newer to some of the newer products, let hospitals like Texas Children's and others across the country do some more of the heavy lifting for you and working out some of those kinks in finding out what best practices are. And then I like to say, then, let us do all the dirty work, and then you just pick up the ball and run it across the goal line and have successful babies. Because that's what everybody wants. So that's what I hope to share with you. My role now, I'm at the University of Texas at Austin. We just opened a brand new medical school there. We haven't even graduated anybody yet, so we don't actually have doctors coming out of it yet. But I've been able to pick up my research role, and now I do less clinical, but I train doctors on how to do research. So that's really exciting, and then I can always tell them, also for our dietitians out here, how to spell dietitian right. Appreciate that. There's no C in dietitian. And put the word referral right before it. Thanks. That's all you need to know. I try. So nutrition is a challenge. One thing that Terry spent a lot of time talking about was how growth impacts those long-term neuro outcomes. And those are easy words to just say, but then I just want to kind of put more into that. I'm going to, spoiler alert, my second talk of the day a little bit, talking about we've been bringing back kids from the NICU at 2 years of age and starting to look at those longer term outcomes. The data that we don't have published yet, that we're still working on and working on that manuscript, is looking at those long-term outcomes where we brought kids back to do Bailey's exams to look at their cognitive function. And then that sets you up for how well do they do in school. That sets you up for what kind of job do they get? What kind of productive member of society do they get? And it really does come back to this first 1,000 days of life and how do we feed babies. And so what a privilege that this group of people in this room, all of us have in impacting a person's future. That's really what we're doing. It's great to be able to say like, oh no, I save babies' lives for a living. That's what I do on a daily basis. But beyond that, I help these babies. The time that they have in the NICU is such a critical window that really is impacting them, their brain function, and how that relates to how they do in life for the rest of their lives. So we have such an honor to be able to work with these young ones to be able to do that. There's so many challenges to get babies to grow. They have higher nutrient needs as preemies. They have respiratory problems, and so we have to restrict fluid volumes. And so we have to manipulate their feeding strategies in order to meet those fluid requirements. We have to make sure that they we want them to have breast milk, but not every mom makes the same breast milk. This mom over here makes 20 calories per breast milk just fine. This one over here makes 14. So, and I get this question a lot too. What can we tell mom? What can mom eat to change her breast milk? If there was an answer I could tell you to that, I'd be a millionaire. Because there's nothing. It doesn't work that way. You can change the breast milk slightly with something. So they found if you take mega doses of vitamin D by supplementing pills and stuff like that, then you can get more vitamin D out in your breast milk. But that's not a food chain. That's taking a medicine, basically, right? So when it still comes back to what foods can mom eat that changes her breast milk, you cannot say, go out and eat a cheeseburger and milkshake and fries, and we're going to get you from 14 calories to 20 calories. It doesn't work that way. One of the tiny things that you can change is if you have a mom who never eats seafood, and all of a sudden she does start eating salmon 3 to 4 times a week. You can change tiny amounts of the fatty acids in there. So you can change the DHA content of the milk, but it's still not going to change the total fat content. So that's really one of the few ones that I can think of that's an actual food that you could do, but otherwise, breast milk is just going to be what that mom makes. Other problems here, one thing that I want to talk about too is with continuous feeds. Our lab did an in vitro study where we just did like through the tubing, and then we ended up with a beaker at the end instead of a baby at the end. But we were able to measure, looking at how much fat is lost because human milk fat adheres to tubing. And up to 40% of the fat in human milk adheres to the tubing during continuous feeds and does not get to that beaker, does not get to that baby. It stays stuck in the tubing. And so if you have a baby on continuous feeds, or even feeds like for 2 hours, or even greater than, so continuous feeds is the worst, over 2 hours is slightly less bad, even over a 30-minute period you're gonna get some fat adherence to the tubing. So if you have kids on any of those feedings and they're not growing, and they're on human milk, it's because the fat is sticking to the tubing and not getting to the baby. So these are all kinds of challenges that we face. So it's not always just the dietitian's fault. Why isn't this baby growing? You only gained 10 grams overnight. Okay, well he's on continuous feeds of human milk, and we want to use human milk because of all the great things of human milk, but we've got to be smarter about the strategy of using human milk. So that's what we're going to keep talking about today. There's great recommendations, great resources for how much protein should babies have. It all floats around that 4.5 to even 4, that 3.5 to 4, maybe up to 4.5 for very low birth weight babies. But we've got some really great data on that. Just to make sure our mother-baby crowd is in line with our NICU professionals here, premature babies, because they're born prematurely, and breast milk doesn't really provide as much nutrition that the preterm babies need compared to term babies. We have to provide that for them, and we do that in the way of fortifiers. Fortifiers could be liquid or powder. They could be cow's milk based or human milk based. So lots of different ways that we can utilize human milk powders. I put together this timeline of just to remind us of like how long have we been using fortifiers, and how has the landscape of fortifiers changed over the years. So our very first fortifier was available to us back in 1983. It was the first powdered HMF available. Then a couple of years later, there was introduced a liquid HMF, but it wasn't concentrated, so it was a very large volume, and we were displacing a lot of mom's milk when we used that. So that was the right idea to start with, but the technology wasn't there to make it a very useful product. So it kind of phased out too. In 2000, the second powdered HMF product came on the market by a different company. 2006 is when we got our first, the human milk-based HMF. 2011 was the first time that really we had the technology to have a more appropriate liquid HMF, and that was an acidified liquid HMF, cow's milk-based protein. So we were able to switch from powder to liquid by using an acidified product. I'm going to talk a lot more about these differences between acidified, and what came next was the non-acidified. So the same company in 2013 made the first non-acidified liquid concentrated HMF. It was reformulated very quickly the year after to the hydrolyzed protein liquid concentrate. So HPCL is the name that goes by, the hydrolyzed protein concentrated liquid non-acidified HMF. What a mouthful. So we'll go through some of the more details about that, but it's just kind of a great reminder to see where all of these have come from. So of course we've got cow milk based. We've got human milk base. There's different ways to utilize each of them. Typically with our cow's milk base, we don't start that until babies tolerate about 100 mLs per kg of feeds, whereas with the human milk-based HMF, we can start that earlier. Because it's human milk, they tolerate it better, so we can start it earlier. And we can go up to higher concentrations with an HMF made from human milk than we can with the cow's milk-based. So when we talk about growth and donor milk as well, I just wanted to toss this in here to remind us again, just like when a baby's not growing, well, checking are they on continuous feeds and how much of the fat is adhering to tubing. Are they getting breast milk from mom, or are we using donor milk, and how much of the feeds are coming from mom's milk and donor milk? Typically, donor milk often is lower in some nutrients than mom's milk. But one thing that we found here is that we did a study, and so Houston and San Antonio are only about 3 hours away, but we found for some reason that the moms in San Antonio made lower calorie milk than the moms in Houston. And I don't have any reason why. And again, I can't explain it by maternal milk, because maternal diet, because that doesn't work that way. But when we analyzed all of these samples, then that's what we found too. We also found that we were using different donor milk locations. So in the study that we did, it was a study looking at cream where we got some of this data. The donor milk coming to us in Houston was coming from the human milk Prolacta company, whereas the San Antonio group was using the H&Banna milk bank in Austin. And so that we found that the H&Banna milk wasn't giving us 20 calorie per milk. They were giving us 19 calorie per ounce milk. And you know, 1 calorie here and there can make a lot of difference. So we worked with, so there's no regulations that H&Banna has to absolutely guarantee 20 calories per ounce. And so a lot of the H&Banna milk banks weren't testing for that and weren't able to guarantee that. So we went to them and said, we'd like to still buy from you, even after using the study, our group in Houston, we'd like to still support the H&Banna group, but you're gonna have to give us 20 calories per ounce. And so they agreed to that. So if you are consistently or even inconsistently finding maybe, well, this baby's also still not growing and he's mostly on donor milk, well, talk to the H&Banna milk bank that you're getting your milk bank from. Are they able to guarantee? So maybe you're getting 18.5 calorie per ounce milk. Maybe you're getting 19 calorie per ounce milk. So when you think you're going up to +6 or different things like that and getting like 26 calories per ounce, and this baby should be growing like he's getting 26 calories per ounce, well, maybe he's only getting 24.5 calories per ounce. Okay, well then, that could be a difference too. So just having conversations with is it the San Jose milk bank that you guys use here? So having conversations with them too about can you guarantee that we'll get 20 calorie per ounce milk? After we did that too, then Austin Milk Bank came to us actually and said, are there any times when you'd like 22 calorie per ounce milk? Because sometimes we get batches that we could do that with. And so we were like, well, let's talk about that too. So those might be options that you could consider. Okay, so I'll talk more in depth about the human milk products, human milk fortifier products. And these are, again, some of the differences. You can see that some are made from intact casein or partially hydrolyzed, completely hydrolyzed. And at this point, too, just to make sure that before I go into the rest of the talk where I use terms like acidified versus non-acidified, I want to make sure that you understand what those products are. So for one time in our CE talk, I am going to identify what these products are just so that you know what I'm talking about. The acidified liquid HMF is made by Enfamil. The non-acidified liquid product is made by Similac. And then the human milk-derived HMF that I'm going to be talking about today is Prolacta. There's a couple of other human milk-based HMF products on the market. As far as I can tell, they don't have any peer-reviewed publications that I can source from to tell you about. So I'm not going to talk about them. So I'm just going to tell you what's in the research. And so acidified is the Enfamil, non-acidified is the Similac. So you can think about maybe what you use in your unit. And then also keep in mind, though, as we go through all of this, keep in mind of how often do contracts change sometimes, and how often do you switch and go back to another company. And just because you're as we go through and you're like, oh, I'm good, we use this one, so we're good, and I can fall asleep now. Think about being that voice whenever it comes time and there's contracts changing, and not to say to pick one over the other, but there's definitely, I'm going to show you some very good evidence of why some of these products are better than others. Because I have seen people, I think, taking step backs in units because of budgets and finances. And well, this one's cheaper, so this is what we've got now. Even though I would say it's a more inferior product, but it was cheaper. And so units have been going backwards. So don't just think like, oh, we're good, we've got this one. Think about how you can keep this information so that you can be that voice to speak up and say like, no, we have to do what's best for the babies. Okay, so I think very few units are using powdered, but because of the availability of liquid now. But there are still hospitals out there using powder, and there are some that have gone back from liquid to powder. The issue with powder is that back in 2011, there were 13 cases of babies who contracted meningitis that was traced back to contaminated powdered formula. Contaminated powdered bottles of formula given to the baby. What most likely happened, because they ripped apart manufacturing plants and the bacteria was not found there. Where it was mostly found was the countertops in the households. So this is, it could happen in a NICU, especially if you're not using a milk bank preparation area and have milk techs who wipe everything down with Lysol at the end of the day and at the beginning of the day and halfway through the day. And if you are doing bedside administration of the products, then there's a potential for that. So powdered can't be sterilized. Liquid can be sterilized. So that CDC, everybody has said we should move away from powdered because 2 babies died even. So, that's not what if there's a better product available, let's use that. So that's where the shift has gone from using powdered, away from using powdered and going to use liquid. So it's hard to get big groups to agree on a lot of things, but this is one of those things that all the big groups agree on. The CDC, the FDA, the AEP, the WHO, they all say for these babies that if they're immunocompromised, we should be using liquid. And in fact, at Texas Children's, we would try our best to send them home on any kind of liquid preparation that we could, even just out to 44 weeks post-menstrual age is what the AEP came out to say. So try to keep them on liquid. If they were in the NICU for whatever reason, then they're not our general healthy term baby. So healthy term baby, okay, go home on powdered formula if you are not breastfeeding and providing all of that. But if you had to stay in the NICU, then you should continue on liquid for at least up to 44 weeks. Why some hospitals still use this? Contracts, budgeting processes. Some people say they still don't want to displace human milk. There's a lot of bad reasons why people might do that. So we're trying to avoid that. When we move on into what does the nutrient composition of these products look like, a couple of things to look at on this slide is that the acidified liquid HMF will decrease the pH. And we'll talk a little bit about what are the consequences of that. So when they created this product, one of the good consequences of that was if they could acidify the liquid, they could get more protein into it. So that's why they did that. And then you can see on the protein line too, it's the highest protein content of all of the products available. So the non-acidified and the human milk-based liquid fortifier are going to have lower protein contents because they're not acidified. A lot of the other things are the same. The acidified product also has more iron, so you still need to add iron if you're using the non-acidified liquid or the HMF made from human milk. This is the first, so I'm going to go through a lot of studies, but I'm hopeful, again, think of it as I did the heavy lifting by pouring through all of these studies, and now I'm going to give you the highlight reel. And so you don't have to go through and read all of these boring studies. So that's what I'm going to do. This first study was looking at powdered HMF compared to human milk HMF. And so, we'd love to see a comparison with liquid too, but this study already cost like $1 million, so we're not going to repeat it anytime soon. And that's also what happens in research as well. But in the blue, you can see that's where the exclusive human milk diet is. Exclusive human milk diet is mom's milk or donor milk with a human milk-based HMF product. There's absolutely no cow's milk proteins introduced into that. The yellow groups are where we do have cow's milk protein. So at the time that we did this, the standard of care was if mom didn't have breast milk, some facilities, this was like 11 different sites, so some facilities were already using donor milk, so maybe they got donor milk, but they definitely got a cow's milk-based HMF. And then some facilities weren't using donor milk, and so if you didn't have enough mom's milk, you got preterm formula. So that was our standard of care back then. And what we saw was that the study was powered to look at neck, and we found that the exclusive human milk diet reduced the incidence of neck by 50%. It dropped from 16 cases to 9 cases, and surgical neck was dropped by 90%. And these, again, in babies less than 1,250 grams birth weight. So this was an incredible study to look at to say if we just change this one thing in our practice and go from a cow's milk-based HMF to a human milk-based HMF, this is the differences in neck. So very exciting, and immediately what one research project does, I have the best job security because as soon as we're wrapping up one question and figuring that out, the next question comes along, and I'm just like, just like hooked right in of like, well now I need to find out what that means, and like now I want to know what the outcome of that thing is. So I told my boss, you got such a sucker because I'm so curious. I have to know how everything goes, so I'm never going to quit. And so that's also what's happened. So there was the next paper was also looking at powdered HMF, which again was our standard of care then, versus the human milk derived HMF. And we I don't know if it was a great title or a horrible title, but we called it Beyond Neck. And it's a really easy title to remember because we looked at all other outcomes. Okay, now if we have great outcomes for neck, what else can we do with this stuff? So we started looking at that. It was a 4-site retrospective study. So all of these sites had introduced the human milk-based HMF. And so we went back and we did chart reviews and we looked at, okay, how did babies do before? And then here's where we introduced it. And then how did babies do after? So this was about 1,600 babies in that comparison. And here were our outcomes. So we repeated, which is always a good thing in research, is to test something again, see if you get the same answer. So we repeated that those neck and mortality outcomes, and were highly significant that the babies getting the human milk-based HMF did better and had less neck and mortality. Growth was the same, which I'm fine with at this point because it showed that we had better health outcomes and we didn't sacrifice growth to get there. So of course I would love to see the babies in our experimental group have even better growth, but I'm satisfied that we didn't even sacrifice growth. But some of the other benefits that we saw, the beyond neck, was a decrease in late onset sepsis, and I think that has a lot to do with the fact that these babies can tolerate this product earlier, and we can advance faster, we can get to higher concentrations faster, and we get lines out faster. That is really important to us. So late onset sepsis went way, way down. Other things that we're really impressed with to see was a decrease in ROP and a decrease in BPD as well. So again, I think it's having to do with providing a better nutrition source to those organs and able to enhance the maturity of those organs a little bit faster in order to help the baby to do better. Okay, so I said I'm going to talk about the consequences of that acidification process. And again, I props to that company for providing us with that first liquid product that was useful to us because, the CDC had just come out and there was this big scare and babies have died and what are we going to do? And so one of the companies did step up and provide it. But with the acidification process, there are some sacrifices made, let's say. So we know that preterm babies are at an increased risk due to lower renal capacity to excrete acid. They also have a lower threshold to hold on to bicarb. So we already have a baby that's going to have some difficulties handling an acid load. We know that there's consequences too when this happens is that they don't gain weight very well. We also know that the acidification process, because of that acid, calcium and phosphorus are going to go right out in the urine, and they're not going to go into the bones. So we're going to have rickets, we're going to have broken wrists, we're going to have fractures, we're going to see some of that. And giving the babies an extra acid load may be a little bit too much of a hurdle for especially preterm babies who are already set up to not handle this very well. It may be too much of a hurdle for them to get past. When the researchers have looked at it more from a scientific perspective in those in vitro studies again looking at cell absorption and lab science, they saw that by giving that amount of acid, it decreased white cell count by 76%. So we're wiping out some of their immune function already. It also helps, not helps, it also, well, it does help to go against, but it diminishes the bioavailability of both protein and fat. So all of a sudden, your lipase is decreased by 50%, your protein is decreased by 14%. That's why we don't have good growth. So because the baby is not able to utilize the nutrients in that human milk product because of the acid that they've added on top of it, that's why they're not able to utilize the nutrients, so they can't grow. At Texas Children's Hospital, we quickly adopted that acidified liquid HMF product because we're like, okay, we got to use a liquid, we've got one now, let's start using it. And at the beginning, everything was fine. And then we started hearing from other hospitals, like, you know what, our babies aren't growing. They're not growing on this stuff. And we're like, oh, our babies grow fine. What's the matter with you? And then we'd start hearing more about, like, you know, have you checked their bicarb? Like, our babies' bicarbs are really high. And we're like, oh, shut up. You don't know what you're talking about. You're paranoid. It just has acidified in the name. It's not like we're giving them acid or something like that. But we are. We're like, we're not seeing that. Okay, so then somebody at our hospital decided, well, you know, we keep getting calls about this. Other hospitals keep asking us about this. We have a lot of babies. You know, every once in a while somebody's mentioned something. Maybe we should collect some data. Yeah, a QI project, that's what it is. Let's just collect some data on a QI project. So, hey Kelly, we need some data. Okay, all right, I'll get you some data. Okay, so then I start like recording actual things. And actual things can tell you a lot of things when it's like anecdotal. My boss's favorite quote is, I didn't plan to say this, so let me get it right in my head. The plural of anecdotal is not data. You can't just say, oh, we keep seeing this, so it must be true. Show me the data. And so that's what we did. We looked at the data and we started looking at how many of our kids have high bicarb. How many of our kids are dropping below 15 grams per kilo per day? If this is the only thing we've changed, and we haven't changed any other funky stuff, well, you gotta say it's that, right? So we started looking at it, and lo and behold, our babies weren't growing very well, and our babies had a bunch of high bicarbs. That was just a QI project, and we actually didn't publish that. We should have. But fortunately, other people did publish that kind of stuff. What we did was we just kind of were like, oh, crap. And then about that time is when the non-acidified liquid product came out, and we were like, oh, thank goodness, we'll just use this instead. So that was our experience. But great other researchers have actually published some wonderful data that we have. I skipped over a bunch of older ones, and we have some brand newer studies that I want to share with you. So this first one was the first prospective head-to-head comparison. So a lot of hospitals had published, like we had done, kind of a retrospective of how did our babies do before we started using this acidified and how our babies doing after, which is a great before and after kind of useful way to interpret data. But this was the first prospective. They were like, okay, we are for sure gonna know we haven't changed anything else over time because we're all gonna do it right now. So it was a little bit of a small study. I mean, it could be smaller, but they had about 15, 16 babies in each group. It was randomized. It was unblinded, which is unfortunate, but just how those hospitals were able to mix it up. They didn't have a milk bank area, so you have to either use product A or product B that's labeled. So there was that little bit of a caveat to it. And then everything else was very standard of fortifying to 24 calories per ounce, starting when they reached 100, all of that sort of thing. And what they found was the babies fed the acidified liquid. They had higher protein intakes. They got about 4.2 grams of protein per kilo versus 3.7 grams of protein. Calories were the same, but even with higher protein and same calories, the babies getting the higher protein from the acidified product did not grow as well. So once again, it's because the babies aren't able to utilize those nutrients because of the acid load. they saw, and the babies in the acidified group had a much higher, there were 25% of them had to have feeds stopped for more than 24 hours because of abdominal distension, versus none of the babies in the non-acidified. So it was better tolerated if it was non-acidified. And they grew better. They looked at growth velocity, and then they even broke it down between mother's milk and donor milk. Babies grew better on mother's milk than they grew on donor milk, but they also grew better if they got the non-acidified product compared to the acidified product. So this was a really great study to look at. This also is just a great visual to show, because I always like to talk about growth in grams per kilo per day, but I also like to talk about it in percentiles on a growth chart. And z-scores are representative of percentiles. So the green line, so we'd like to see their z-scores not going down. And so that's what we see with the green line, which is the non-acidified liquid product. Whereas you see the red line, their z-scores are just going down, which means if you were to look at what that would look like on a growth chart, that means flattening out. So that baby is not going anywhere. And we've all seen those kind of growth charts. Then they also looked at, okay, well, what are those bicarb levels? What about, are they in metabolic acidosis? And what they found was the babies who were getting the acidified product definitely had metabolic acidosis compared to the non-acidified liquid product. The retics were a little bit higher in the non-acidified liquid human HMF group. They think that might have been due to the supplemental iron that those babies were getting, because there's already iron in the acidified liquid HMF product. But that just needs to be, we need to have a little bit further explanation about that. So, but overall, the non-acidified liquid HMF was associated with better growth and less incidence of metabolic acidosis than the acidified one. Okay, so that was the first prospective head-to-head comparison at one site. And then the next year, Dr. Chandler came out with a multi-center prospective head-to-head comparison. And so there were these 5 sites listed here, randomized, parallel design, again, unblinded because of how their units were set up, and they all added the HMF when feeds reached 80 per kilo per day. And so these are some of our results that we see out of this paper, is that we've got differences that, again, there's more protein. There's 4.3 grams versus 4.1 grams. There's more protein that the babies are getting in the acidified product, but and no caloric difference, but they are growing worse. So this is just showing that they have more protein in that group. In the red bars is the acidified group, the blue bars is the non-acidified group. The first block is the intent to treat group. The second block is, so that's everybody, all comers, everybody that they had. The evaluable data means if they were missing one bicarb, like 1 week, the attending forgot to order the bicarb for the study. Then they got tossed out and they were only included in the intent to treat group. The evaluable group means that they had exactly 100% of all data points for everything. It was a perfect study done. And so they compare it that way. In both groups, it's a wash because they're the same. In both groups, despite greater protein intakes in the acidified group, the non-acidified group babies grew better. And that was both the first 2 weeks of the study period and the whole first month of the study period. So again, we're seeing better growth with the non-acidified product. Better tolerance as well. So better tolerance as for feeds held due to abdominal distension, feeds held because of gastric residuals, feeds held to vomiting, and all of those, the babies had better feeding intolerance when they were on the non-acidified product. And then finally they looked at what are those bicarb levels. And here you can see such a dramatic difference between the red group having much higher bicarbs than the non-acidified liquid HMF products. So they don't grow as well on the acidified product, they have higher bicarbs, even despite the higher protein. So what we might see after all of these publications is, if I were that company, I'd be working on a reformulation right now. So it might be that comes out and happens, and again, like though, they were the first to help us out with this. So I don't fault them at all. They figured out a way. They were like, well, we need to provide a liquid product, and we got to make babies grow with protein. So here's how we can do it. So I give them credit for that. And then another company came along with, okay, let's take that and do better. And so I think that's where we're always going, is like, let's take what we've got and do better. All right, now let's take what we've got and do better. So hopefully we can keep learning about that, and that's also kind of what gives us all job security, is that things are constantly changing, and so we've got to stay up to date on all of those things, and that's exciting because then we're constantly making incremental improvements for these babies, and that's what, again, this all comes back to. So. That's kind of all I have to say about fortifiers. I want to talk a little bit about, so fortifiers being, we gave them protein and vitamins and minerals and some carbohydrate and some fat. We did all of that. What about just giving them one of those nutrients? And that's where the cream product comes in. So we did a study looking at cream. What we did was, this was at 2 different sites. Again, this was our Houston and San Antonio sites. If they were in the control group, then we just recorded their data. And if they were in the intervention group, what we did was we measured mom's milk or donor milk, and if it was less than 20 calories per ounce, then we gave them the human milk cream product to bring them up to that. So if they were 19 calories per ounce, then we gave them 1 calorie per ounce of the cream to bring them up to that. If they were those babies that were 14 calories per ounce, then they got enough. They got 6 calories per ounce to bring them all the way up to 20. And then we looked at all of their growth outcomes for that as well. So what we did was, it was about 80 infants, 40 in each group, and this is again where we saw some differences in human milk that were just kind of interesting. Again, that the moms in San Antonio versus Houston had slightly different caloric amounts as well. And so here are our outcomes. The babies who got cream grew better. So again, that's also just because we're making sure that they're really getting what we say that we think we're giving them. It's all based on, you see our dietitians around with our calculators and everything, but it's all estimates, and it's all based on assuming that breast milk is 20. So if that breast milk is not 20, all of our calculations mean squat. So the control group, which was the group of who knows what they got, because it could have been less than 20, maybe it was 20, maybe some mom had 21, but whatever. We know that the cream group had better growth. So they had better weight velocity, grams per kilo per day, their length was better, and their head circumference was the same. So we weren't able to get the change in head circumference. But that's okay a little bit, because sometimes especially in the world of nutrition, where you hear things like, oh, something like, we heard this a lot with vitamin D. Vitamin D, if you have low vitamin D levels and take vitamin D, you will cure cancer, you will cure heart disease, you will, lose weight, you will regrow hair, you will, like when it starts to become like you can do everything, it's a miracle pill, there is no such thing. So sometimes it's kind of like, okay, well, it makes sense that head circumference growth is the hardest one to move the needle on. So, okay, of course we always want to do better. We also looked at, so we know that short-term growth, because of the cream, was improved. Other things that we looked at was, after adjusting for gestational age, birth weight, and BPD, the cream group had decreased length of stay by about a week. And then it follows that they had a lower PMA at discharge because they went home a week earlier. So those were exciting things to see as well, that just like when we switched and we started using the human milk-based HMF, and we know that we can advance faster and they tolerate it better, so we get those lines out, and so that makes sense. This makes sense because we are providing more nutrition for what they actually need, and we can get them to full feeds faster. We can meet all of their needs faster so that they can go home earlier. And so we were very excited to see that. We did a subgroup analysis of about 20 babies out of that 80 that had BPD. And we were hoping to see the same thing, but we didn't quite get there. So we only had a p-value of 0.08 rather than 0.05. So we can, in those statistical terms, we can say that there was a trend toward significance, but it was not significant. Part of that too is that we didn't start out looking at BPD kids, so if we had 80 BPD kids, then this data tells us that we might have reached statistical significance to show that BPD kids on cream would go home earlier. And in fact, what we saw here was that they went home 17 days earlier. So it was even better for the BPD kids than even our regular kids. So hopefully we can have some more data on this, and hopefully we can show that it really does show an improvement for decreased length of stay for kids. Okay, there was another study out of Portland, and I'm going to go through this and then just mention the last section. But what they found too was that the earlier day of life that they were able to reach 24 calories, the better the babies did. So that came into play because they were using an HMF based on human milk, it could get there faster. So even thinking about those little 23, 24 weekers, if you use a human milk-based HMF, you can get them to 24 calories faster than you can with a cow's milk-based. So if you're still using the liquid HMF, you'd have to wait till they reach about 80 to 100, but with our human milk-based one, we can get them that faster. Getting them there faster led to increased weight gain overall and length gain overall as well. So we're seeing better length and weight gains when we're able to get, so it's just kind of a different way of looking at it, of how fast can we get to 24, and get there safely and well tolerated and all of that. Okay, so the last bit, there's three main ways that we can fortify human milk to make babies grow. So there is what we call a standard fixed dose enhancement of breast milk. So that is providing 4 packs. That's providing +6. That's providing a certain amount to a certain amount, to 100 mLs. Okay, so we do this all the time. It's very easy. Lots of pros to this. It's easy. There's very little training involved. All of that kind of stuff. But maybe it's not the most specific. It's not individualized because we're assuming 20 calories per breast milk and we're adding 4 packs or +6 or something like that to it. Another way you can do it is an adjustable fortification strategy. This is basing your fortification on a BUN level. So this is trying to get there of like, let's be more individualized and looking at a baby's actual needs and looking at, okay, if a BUN is 9, we might give this. If a BUN is 12, we might give this, and trying to individualize it that way. Targeted fortification is where you're actually analyzing the breast milk, and then, like we did in that cream study, to say this mom's breast milk is 19 calories per ounce, so I'm going to give this strategy. This mom's breast milk is 15 calories per ounce, so I'm doing that strategy. So again, more individualized to the baby. It's more expensive, of course, than our first group. So basically, if you've ever seen this little sign, good, fast, or cheap, you can have any 2. Pick 2, that's all you get. So that's kind of where it comes out with these fortification strategies. There's lots of information in your slides to take home about it, pros and cons. We've talked about the standard. It's so easy, there's no equipment, there's no training, but there's limitations. We're assuming it's 20 calories per breast milk. We're assuming certain things. We're assuming all babies are going to grow the same, so we're not looking at any labs. We're assuming all of these things about it, so there's limitations to that. Adjustable fortification has very little consensus. If it's at 9, and the thing about it is that it looks at BUNs for babies, but that's not always a good surrogate for protein management in very, very tiny preterms. So it's not the best indicator for the actual population that we want to look at. And then different strategies are out there, and people follow all kinds of different things. Like if it's 9, this one has a cutoff of 12, that one has a cutoff of 14. Now it's too variable, and we can't compare data from one site to another site. Everybody's doing it kind of differently. So it's really difficult. Lots of limitations to that. Targeted does actually measure the milk. It actually measures the milk that baby is getting, so there's lots of benefits to that. It uses a spectroscopy machine where a light source goes through a sample of the breast milk, and it actually measures the protein, fat, and carbohydrate. And then from that, you can calculate the calories, because that's our macronutrients, where we're getting that from. You only need a small amount. One of them uses 10 mLs, but a lot of them use 1 to 5 mLs of a sample. You do need to have it pooled, so a 12-hour sample pool or a 24-hour sample pool. So if you don't have a milk bank where that's possible, then that's another limitation. The machines were, is that me or not? Okay, but I'm almost anyway. So these machines run about, let's see, I'll go back a little bit. So these machines are different from what a chromatocrit is. So I think many people in this room might be familiar with a chromatocrit. It's basically a big centrifuge and it'll separate the fat from the rest of the components in the human milk. A chromatocrit only measures the fat. It doesn't measure protein, it doesn't measure carbohydrate. So it's basing those calculations for calories on assumptions of, okay, if your fat is this, then we think your protein and carbohydrate will be this. But it's all assumptions and it's not actual measurements. There was a big study that looked at and found that the chromatocrit significantly overestimated the calories of human milk compared to a spectroscopy. The chromatocrit said that human milk had 22 calories per ounce. In reality, it only had 17. That's a big difference. So I don't like chromatocrits at all anymore. The problem with these machines, though, is they're a little pricey. I mean, somewhat. You know, how much is a milliliter? But they're about $65,000. You need to have training. You need to be able to have a setup where you can have that done. So some of the larger institutions are investing in this, and then they're able to measure mom's milk. But a lot of studies are kind of getting around this by saying, well, if the baby's not growing and if they're not on continuous feeds, like if we can go through a checklist and everything else, and we've talked to San Jose HMBANA, and they're guaranteeing that we're getting 20 calories per milk, and we've done everything else, okay, well then we're just going to assume that mom's milk is not 20 calories per ounce, because it's probably not. And so, do we really care if it's 17 or 18 calories per ounce? Not so much, so we're just going to make more assumptions about things, and let's go ahead and maybe add a cream product to that in a fixed dose. So it's kind of a blend between that standard fixed dose approach and the targeted approach, and so that you kind of blend things together and say like, okay, well instead of analyzing mom's milk, I know that if I can add 4 mLs per 100, I will increase, by using a cream product, I'll boost her milk up by 2 calories per ounce. And so do I really care if I'm getting from 17 or 18 and I'm already at like a +6, which is really now only a +3 or a +4. Okay, so I can add 2 more calories. So these are all the games that dietitians play. So this is how we manipulate the products that we have available so that we can make the baby grow. So those are the games that we play. So we've talked about it a lot today. I breezed through the last bit, but because the first bit I think is more important. But you've got those slides there. We've talked about how that we have different strategies to feed babies to make them grow. We talked about length and weight gain. I do hate to sacrifice any head circumference growth because again that is directly related to brain growth. That's directly related to cognitive outcome functions. So I think we still have opportunities ahead of us where we can do even better with that. So with that, I'll leave you with pictures of my farm. This is our cattle ranch here. This is my Uncle Bob on my grandpa's tractor that's over 100 years old and still works great. And it's always just a great reminder to me that sometimes you can get all this technology in the world, and sometimes the things that really work the best are back to the basics. Which then okay, well then what does that mean for me? Okay, well that's really just human milk. Like, can we just talk about human milk? Can we just talk about colostrum? Can we just talk about that? Technology's great. We need it. We've got, that's how we're saving 23 weekers. So we need the technology part, but let's not forget about those basics as well. So anyway, thank you so much.